Okay guys, so the next section is going to be adding and subtracting rational expressions. This is the tough one. I think this is probably the hardest section of the unit that we'll be working on. We'll start it nice and slow and we'll kind of ease into it. We'll get to some nasty stuff by the end. Let's take a look at some simple fractions, right? Let's remind you how this works. Uh, the key word here, like denominators, those are your friends. And what does that mean? That means that the bottom of the fraction are the same. So those threes match, which makes it very nice for adding and subtracting fractions because you don't have to do anything but keep the bottom and then just add the top. 1 plus 5. 1 plus 5 is 6, so 6 over 3. And we know 6 over 3 is 2. So that was pretty easy. Oh, yeah, also remember, if you have any questions, go ahead and jot them down in this section right here, and I'll come around and answer them as needed. Okay, the next section, let's take a look at this. What if I threw a variable in here? Would that make it any different? They both have like denominators of 3, so the base stays 3. And then the top is just going to be, this variable x minus 5. So x minus 5. That's it. That's all you can do. It's pretty easy. Again, what if the variables are on the bottom? That doesn't really change much. If the variable's on the bottom, you got a 3y squared and a 3y squared. You just leave the bottom 3y squared. And the top, you add. So 7 plus 5, well, 7 plus 5 is 12. So there you go. You could reduce that if you'd like to. You'd say 12 and 3. We know that those kind of cancel a little bit, giving you a 4 on the top and a y squared on the bottom. That would also work as well. Okay, let's go ahead and take a look at the next one. If you have any questions, go ahead and jot them down. Now we're going to start working into some more complicated looking expressions, but really it's the same as what we've been doing. So if you look here, these two match perfectly, and if they do, you can just go ahead and leave that on the bottom, this 3x times 2x plus 1, and then the top just add together like you've been doing together. Well, in this case, you're minusing. So 9 minus 3, so 9 minus 3, that's going to give you 6, and then you're done. Well, before you're done, you might want to reduce. If you look at the 6 and the 3, we know that those two will cancel, giving you a 2 on the top, because it'll be a 2 instead of a 6. And you'll have just x times 2x plus 1. You can cancel it there. That would make it a little prettier looking. Okay, next problem. Let's take a look at this. Now, it looks like they're not like denominators because of this, but if you just do a little bit of factoring, we know that's the difference of two squares. We have y minus 3, y plus 3, and what do you know? That matches the other expression. So this will match this. So we know we're good there. So what we'll do, we'll just leave the bottom as is. Okay, so the bottom stays as is. We're going to have y plus 3, y minus 3 on the bottom. And then on the top, we'll have 2y plus 5. So 2y plus 5. You can try to factor that out. I would just leave it as it is. That's perfectly fine. I'm okay with that. So there you go. There's two. That's all like denominators. So those are the easy ones. Those ones are your friends. The unlike denominators is where it gets a little more complicated because, remember, you cannot add and subtract fractions unless you have like denominators. So in this case, the denominator here is a 7 and a 3. So what you're going to want to do is multiply by something to change it. Well, the least common multiple between those two is going to be 21. So 3 times 7 will give you 21, but I have to multiply the top and the bottom on this expression. And same thing over here. I'm going to multiply this bottom by 3 and this top by 3 because really these 3 over 3 and 7 over 7 are just ones. I didn't change the expression at all. So working that out, 3 times 7, that's 21, and 3 times 1 is 3. And then over here, I'll have 5 times 7, that's 35, and this 3 times 7 is 21. So now we'll add those two together, and 3 plus 35 is 38 over 21, and you're done. Okay, so a little bit of easy, unlike denominators, making the same. That shouldn't throw you off that much if you have a variable at top. You're still going to treat it the same. Multiply the bottom by 3 and the top by 3. Multiply the bottom by 7 and the top by 7. That will give us like denominators of 21 and 21. Okay? And what we're going to do is we'll just leave this as 3x because 3 times x is 3x and 7 times 5 is 35. So put it all together. 21 stays on the bottom. You get a 3x minus 35 and you're good to go. And that's about all you can do. Alright, next problem. Let's take a look at this. We have an x on the bottom, so does that change it? No, not really. It's still pretty much the same. But in this case, our GCF between these two is going to be 3x. So I'm going to multiply this guy by x on the top and the bottom, and this guy by 3 on the top and the bottom. And that'll give me a 3x on the bottom here, and a 3x on the bottom here. And what I'll do is I'll have 3 times 4 is 12, and 5 times x is 5x. And if you go keep the base, keep the bottom, 3x, and then 12 minus 5x. So 12 minus 5x. And yeah, you're done. Okay? So not too bad, not too bad. Some easy ones to get started with, unlike denominators. You've probably done those before. Now let's kind of get into some of the more difficult ones as we move along. So if you look at this example, what do these two right here have in common? Well, if I look at it, I got a 3 and we have a 9, so you would think I need to multiply this guy by 3. That would make sense. And then this guy only has a y, but I need a y squared, so I'll multiply by him by y. Okay? So this one's a little different. You can just quite swap it, but 3 times 3y squared is 9y squared, and 9y times y is 9y squared. So we'll have a base of 9y squared. That's what we wanted. Now on the top, 3 times 7 is 21, and then over here, that'll be minus 5y. And you're good to go. So again, not too bad. Let's see if we can handle this. All of a sudden we have an addition sign in here, or well, a subtraction sign, which makes things a little more complicated, but not that bad. If you look at the GCF between 3x and x minus 4, what you're going to do is just flip-flop them, because you want to have every piece. So I'm going to multiply this side by 3x on the top and the bottom, and I'll multiply this side by x minus 4 on the top and the bottom, and it doesn't really change it too much. It's just a little more complicated. That's all we're doing, is just complicating things a little bit. Well, we know now the base will be 3x times x minus 4. We know that that will be the bottom of the fraction, the denominator. Now the top will be 3x times 9, that's 27x. And then over here, we got 3 times x minus 4. You distribute that. Well, here, we'll write the steps out. 3 times x minus 4. Okay. So now what you would probably want to do to kind of simplify this a little more, distribute this 3 in. So you're going to have 27x plus 3x minus 12. Add 12, but that's a 12. Okay, that's a 12. All right. Divided by 3x times x minus 4. Okay, so that's not too bad. I got some like terms that can be combined. 12 or 27x and 3x, that's going to give you 30x minus 12 divided by 3x times x minus 4. Okay, good stuff. And you're done there. Yeah, we're not going to make you break it down too much from there. It looks like you probably could factor something out, but you know, that's probably just fine for what we're going to be doing. Let's take a look at this next one right here. Okay, so this one's wow, it's kind of hard to see what they have in common, don't they? So I would suggest, in this case, go ahead and factor this guy out. We know this is a y plus 3 and a y minus 3, because that's the difference of 2 squares right there. And that guy, I don't know what that guy is. He's just going to stay as he is. So what's my common terms here? Well, I know I'm going to want to have a y plus 3, because that's in there. I know I want to have a 4, and I want to have a y minus 3. That's going to be my base. All 3 of those things. So putting all that together, in order to get that, I'm going to need to multiply this side by the thing it doesn't have. What doesn't it have? It doesn't have a y plus 3. So I'm going to do that. I'm going to multiply by y plus 3 on both sides. Okay? So now this, the right side of the expression will be equal to the left, but I also need this 4 over here. So I'm going to multiply this guy by 4 and this guy by 4. And then we should be good if you look at that, because now our base is going to be 4 times y plus 3, y minus 3, all divided by 4 times 2y, which is 8y, and minus, this is 5 times y plus 3 in parentheses. Go ahead and distribute that 5, and we'll you know, simplify a little bit. So 8y minus 5y plus 3 divided by 4 times y plus 3, y minus 3. Oops. Y minus 3. Okay. So, like terms, we got 8y and 5y. Put those two together, we get 3y plus 3, all divided by 4 times. Am I doing this right? Yeah, we're good. 4 times y plus 3, y minus 3. Okay. Oh man, did you see what I did? I made a huge mistake here. Let's rewind. You see this part right here? This was my bad. I totally missed that. 5 times 3 is not 3. This should be a 15. That was my bad. So that should be a 15 here as well. Big boo-boo on my part. Yeah, so change that to a 15. Hopefully you saw that. I forgot to distribute that, and that's a common mistake. It's easy to do, especially when you're trying to go fast. But, okay, so we're good to go there. So the next thing you might want to work on is the next problem. So that's as simplified as it goes. Let's take a look at this next problem. And all right, what do we got here? Okay, so this looks like it needs factored a little bit. So let's go ahead and factor this. We're going to pull a 2 out here. That's going to be an x minus 1. We're going to break this down to an x minus 3, x minus 1. That's what that's going to factor down to. So my pieces that I'm going to need to put together, you can kind of see I need an x minus 1, an x minus 3, and a 2. And those would be my base. So over here, we know we're going to have that. What do I need over here, though, to make that happen? I need a 2 on the top and the bottom. So I'm going to multiply by 2 on the top and the bottom. And over here, I need a x minus 3. So I probably should use a different color for that. Let's see. So this should be an x minus 3, and this should be an x minus 3. Okay? So now they'll match. Okay? You see how this side will match with that side? Okay? All right, so in doing that, the bottom is going to stay exactly what we had highlighted. 2 times x minus 3 times x minus 1. And the top is going to be, well, you got x minus 3 times x plus 2 times, this is going to be minus 2 times negative 2x minus 1. Hopefully you see all that come together. Now, foil here. All right, you're going to foil these guys right here. Okay, so you get x squared, and I'm going to do it real quick. That's going to be minus x minus 6. You know how to foil. And then this side over here, that's going to give you plus 4x. Make sure you distribute this too. That's what I didn't do last time, so plus 2. And then over here, you're gonna, this bottom will stay the same. We're not gonna mess with the bottom for right now. We'll just leave that alone. Okay, now bringing it all together, so let's simplify this top. I see that an x squared is gonna stay by itself, but this guy and this guy can come together, giving me a plus 3x, and this guy can come together, giving me a minus 4. And that should be my top. My bottom can stay as it is, and we're done with that problem. That's a bit of a doozy. That one's kind of tough. But, you know, we can handle that. It's not too bad. Okay, so there you go. Let's take a look at the, now you're going to flip your page. You're going to go to the back side. We'll look at some complex fractions. 2 different methods you could do this in. Here's method 1. You try to simplify this top. So here, let me grab my magic pen. I'll show you some magic here. So you try to simplify that first. And once you simplify that, then you work on this. This would be method 1, okay? Method 2, you'll see in a sec, we're going to simplify the whole thing all at the same time. But let's just do method 1 first, and then we'll switch to method 2. So method 1 would be like, okay, 3 and 2, what do they have in common? Well, it looks like 6. So I need to multiply this guy by 3 over 3, and this guy by 2 over 2, and then that should work. So, and then let's do that. We'll do the top, and then we'll come back and do the bottom. So that would give me a 6 on the bottom, a 4 on the top, and this would give me a 6 on the bottom, a 3 on the top. Now we'll move to the bottom. So the bottom, you're going to look at that and say 5 and 3, well, that's 15. So we'll go 3 here and a 3 there, a 5 here and a 5 there. So that's going to give me a 15 on the bottom here and a 15 on the bottom here. We're subtracting 5 times 4 is 20, and 2 times 3 is 6. So putting that all together, this is going to be 6 over 4 plus 3 is 7, so, or 7 over 6, sorry. And then 20 minus 14 is, or 20 minus 6 is 14 over 15. So then what you would do from this case is you would flip and multiply like we did in the last section. So this would be 7 over 6 times 15 over 14. And then you would go, oh, you would say, oh no, look how nice that is. These are going to cancel a little bit for me, making this a 2, this a 1, this a 5, and because they have a common denominator of 3, or a common factor of 3. So you have 2 times 2 is 4, and 5 times 1 is 5. So there's your final answer. That's kind of nasty. It's not my favorite way of doing it. A method 2, I think you're going to like better. Again, we're going to look at this whole thing and we're going to say, hey, inside of this whole thing, do we have something that can make, all of these denominators the same? Well, what's that common factor in which makes them all the same? Well, if I look here, let me get the highlighter out and I'll show you kind of what I mean. I mean, if I take this guy, this guy, this guy, and this guy, what do they all have in common? What's the least thing that they all multiply into? Well, in this case, it's going to be 15. So I'm going to multiply, or no, it's not going to be 15 because 2 doesn't go into 15. How about 30? Let's try 30. So if I multiply by 30 on the top and 30 on the bottom, because that's the least thing that they all multiply into, okay? And then watch what happens when you multiply this across. 30 will cancel with this 3, okay, on the top right here. It'll cancel with this 3, making it a 10. So 10 times 2 is 20. So the 20 is on the top. And then now 30 going into this 2, okay, that'll make it a 15 because they'll cancel, making it 15. 15 times 1 is 15. So there you go, there's the top. And now let's do the bottom. 30 in another 3, we're going to make that a 10. 10 times 4 is 40, okay? And then 30 to this 5, we know that's going to cancel to a 6, right? So that's going to be 2 times 6, which is 12. Okay, so putting that all together, we're in pretty good shape. That's just going to be 35 over 28, and what do you know? That reduces down to 5 over 4. And how much easier was that? That was a little bit easier. If you ask me, find the common denominator for all of the denominators, and then go ahead and multiply by that. Okay, let's take a look at this next section. Method 2 is awesome here because it's going to make our life a little bit easier. So if you're looking at this one, we have x, that's really a 1, 3x, and a 5. What do they all have in common? I think that's going to be a 15x. So if I multiply this top by 15x and this bottom by 15x, let's watch what happens. We got this 15x and this x is going to cancel, leaving me with just a 15. So 15 times 2 is 30, right? Now we're going to go to the other side. 15 and the 1 aren't going to cancel. Remember, there's a 1 there. That's not going to cancel at all. So it's going to be 15x times 3, which is going to give you 45x. Okay, now let's go to the bottom. 15x and then the 3x, those are going to cancel a little bit. The x's will be gone, right? These x's will be gone, so that guy's gone. And then the 15 is going to become a 5 because 15 divided by 3 is 5. So 5 times 4, 20. Okay? And then the other side. So let's take all right, so we get the 15 is going to break down to a 3 because the 5 and the 15 goes to 3. And then the x has no one to cancel with, so 3 times x, or 3x times 7 is going to be minus 21x. Okay, and we're done. That was really nice. That makes it very nice. Okay, this one looks like a beast, but I got a feeling it's not going to be as bad as it looks. Let's go ahead and factor this piece right here. It'll make our life a little bit easier. That's an x minus 2, x plus 2, and you're going to see pretty quickly that our greatest common factor, or our like denominators here, is going to be x minus 2, x plus 2, because it's right here, it's right there. It's in all those spots, okay? So what we're going to do is we're going to go ahead and multiply the top and the bottom by that expression, which I know seems crazy, but it's not going to be that bad. So we're going to go x minus 2, x plus 2, divided by x minus 2. And this is just going to take some practice, guys. You're not going to be good at this right off the bat. It's just going to take some practice. So if we were looking at this, on the top, these guys are going to cancel, giving you 2 times x minus 2, okay? So that's the top. Now on the bottom, the first piece, both of these are going to cancel with both of the red. So I'm left with just the bottom of, well, let's see, just 4, because the bottoms cancel completely. And now this will, let's see, this x minus 2 and this will cancel, leaving you with a minus 7 times x plus 2. Okay, we're making some ground here. Let's keep going. Alright, so distribute and reduce. So that's going to give you 2x minus 4. That's going to give you 4 minus 7x minus 14 when you distribute this guy in. And then combining like terms, we get 2x minus 4 on the top, and negative 7x minus 10. And then you're done. So that's it. That one was a little bit more difficult. Yeah, that one was kind of hard. Okay, so the next one is your turn to try. So I'm going to pause it. You check it. You try these on your own, and then we'll come back to it, and we'll see if you got it right. Okay, so I'm going to pause it. You try. So your turn. So go ahead and pause the video and try. Okay, guys, we're back. Hopefully you did pretty good on it. You can check your answers real quick. If you got them right, just go on and start doing those practice problems. If you didn't, let me walk you through some of those. If you look at this first one, I wish I but let's see. Let's see if we can do this. The first one here, here, we'll use this. This will work. Okay. If you're looking, the first thing I did was this. I factored that. Okay, we factored that, which was great. And I looked, what's the GCF here? Well, you have your x minus 4, x minus 4. There's two of them. This one only has one right here. Okay, so I needed to give it another. So that's why I multiplied it in blue, x minus 4 over x minus 4. Now, after doing that, it coming through, I knew the denominator was going to be this x minus 4 over x minus 4. And then this top was your negative 15x, which stayed. Okay, and then this is negative 8 being distributed into this piece right here. So if you distribute negative 8 in, it gives you negative 8x plus 32. And then you're pretty much done. You just combine some like terms. So our like terms here, we had the x and the x, putting those together, that gives you the negative 23, and you're done. So that one was kind of tough, but I think you could probably do it. The next one is so easy. They have like terms on the bottom, or like denominators, so that makes it very easy. 8 plus 3, or I'm sorry, 5 plus 3 is 8, and you're good to go there. That was easy. This bottom one right here was a little bit tricky. You have to take a look at this because it was a complex fraction. First thing I did was factor that. Okay, I pulled the x out, the GCF, and I looked. Okay, I said, all right, x times x minus 2 is my common denominator. That's what I need to have everywhere. So I multiplied the top and the bottom by x times x minus 2, and that's method 2 for complex fractions, which I think is a little bit easier. So in doing that, this piece right here, this x times x minus 2 is getting multiplied by this guy first, okay? Which the x's cancel, leaving you with 3 times this x minus 2. So 3 times x minus 2 is right there. Now, this other piece, so this piece right here being multiplied by this guy, only the x minus 2's cancel, okay? Leaving you with just an x. So 5 times x is 5x. That's this right here, okay? All right, so you got all that. Now, the next thing you had to do is the bottom. The bottom was real nice because this whole thing just canceled because that's what I multiplied it by. So leaving me with just a 6. All right, so that's not too bad. I distributed this in. That's not a big deal. And once I distributed in, I got this line right here, okay? Combining like terms, I got a 3x and a 5x. That gives me 8x, and I'm done. Just like that. Not too bad. Next one, pretty easy. You just got to remember that this x by itself is really the same thing as x over 1. We knew that. So that's going to be x plus 1 on the top and the bottom because that's the LCM. So if it's on the top and the bottom, when they go to multiply through, the first one's going to cancel, leaving you with just a 5, okay? Leaving you with just a 5. So that's where this came from because that's going to cancel with the other one. All right, now, when you multiply it through on the second one, okay, the x is going to multiply by x minus 1. I kind of wrote that a little bit funny, but that's really still appropriate. And then you have that. So distribute that x in. So if you distribute this x in, right in here and right in here, that gives you x squared plus x, okay? So there you go. And then, so that's 5 plus x squared plus x over x plus 1, which is my common denominator. And normally we would like to rewrite it this way just because that's proper form to rewrite the top like that. We like to put it in the same form. So just go ahead and rewrite it like that, and you're done. Hopefully it went really well for you. If not, ask some questions, rewind it, try it again, and don't forget to summarize, okay? Summarize your work at the bottom. That will be very, very helpful for you if you summarize what the main focus of that lesson was. All right, good luck. We'll see you.